In this activity, we have an airline that has just finished training 25 pilots, 15 male and 10 female, to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced that they will use a lottery to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper, placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. A day later, managers announced the results of the lottery. Of the 8 captains chosen, 5 are female and 3 are male. Some of the male pilots who weren't selected suspect that the lottery was not carried out fairly. Do these results provide convincing evidence of discrimination? When I asked this in class, one student said, "This is random, and it is possible to get 5 female and 3 male in a random selection, so she didn't see any evidence of discrimination." So 5 female and 3 male are possible. So no discrimination. Or at least not enough evidence to show there's discrimination, okay? Another person said, well, wait a minute. There are 10 females, so we have 5 out of 10 females, so 1/2 of the females were chosen. But there are 15 males, and 3 out of 15 males were chosen, so only 1/5 of the males were chosen, and that does seem kind of unusual. So the question is this unusual enough to be evidence of discrimination? So how do we determine this? Now, there are probability rules that can be applied, and we will do this later on in the course, but what I want to show you is a technique that statisticians use very frequently to determine how likely something is to occur, and it's called simulation. So we are going to do a simulation. In this simulation, there will be a plastic bag containing 10 white cubes representing the females and 15 green cubes representing the males. The X's don't really signify anything, they just happen to be on some of my cubes. So what I did is had every student worked in pairs and mix up the cubes in the bag, draw out 8 cubes without looking, and record how many females were in the group, so how many white cubes, and do this 10 times each. So we ended up with a result of 50 different data points, and we made a dot plot of this. Okay, so what we had, this is known as a distribution of data because it shows how the results were distributed. So 4 out of the 50 times we got 5 females in the group, which is what happened in the problem. 14 out of the 50 times we got 4 out of 8 were female. 17 out of 50 times 3 out of 8. 8 out of 50 times we got 2 out of 8 females, and 7 out of 50 times we got 1 out of 5 females. Notice we never got 0 out of 5 females. We never got more than 5 in the group of 8 as females in all of the 50 times we tried this. So calculating the results, we saw that 4 out of 50 times, or about 8% of the time, we got the results shown in the problem. So here's what we concluded as a class. Based on our simulation, there was an 8% chance of getting 5 out of 8 females just because of random drawing. So getting 5 out of 8 is somewhat unusual, since it only happened 8% of the time, but not unusual enough to convince me that discrimination occurred. So here's what we're going to be doing a lot of this semester. We are going to be looking at, if we do something randomly, how likely is it that a particular result will occur, or a particular group of results will occur? If it is likely to occur just by random chance, then we say, then it does not show evidence one way or the other that something unusual happened. But if it is rarely likely to occur, there might be some evidence that something unusual happened. In this case, discrimination. we decided that 8% wasn't unusual enough for us to think something unusual happened. Maybe if it had only happened 1% of the time, or not at all, we would have been very suspicious of discrimination if we'd gotten 6 or 7 out of 8 female, because that never occurred randomly in all of our 50 trials.